Yeah, welcome to Akshar online classes. This is Gafar sir, your physics faculty. Let's start our session. Is my voice is audible?
Yes, sir. Good evening, sir.
Very good evening. So today we'll revise the chapter called optics, that is refraction of light. So shall I revise the topic? Yes, I will revise the topic here. So we are talking about refraction of light. Refraction of light. Refraction of light we are talking now. So here refraction means, what is mean by refraction? Refraction means bending of the light ray when it is traveling from one medium to other medium is known as refraction. Understand? Bending of the light ray, it is bending of the light ray when it is traveling from one medium to other medium is known as refraction. For example, so this is a boundary of the two mediums. A light ray is traveling from one medium, this medium 1 to medium 2. So this is a way. Now here you can draw a normal. This is a normal. This is a imaginary. Traveling from, this is the way the bending takes place. Understand? Bending of the light ray when it is traveling from one medium to other medium. And even you can see, you can observe another bending also. So this is also, you can observe the bending. So this is a light ray, and this is a normal. This is a normal, and when this is a normal, so this is the refracted light ray. So this is also one more bending. So here observe that in the first case the bending takes place towards the normal. So here this is the refracted angle, this is incident angle. So in the first case the bending happened towards the normal. In the next case the bending happened away from the normal when it is traveling from one medium to another medium. So this is why this changes happen. In this case why it is bending towards the normal. In this case why it is bending away from normal. It is depends upon the mediums. Here when light ray traveling from rarer medium to denser medium, the bending takes place towards the normal. Any light ray traveling from rarer medium to denser medium, the bending takes place towards the normal. Here any light ray traveling from denser medium to rarer medium, the bending takes place away from the normal. Here this is angle of incident, this is angle of refraction. Understand? So anyhow, what is this rarer medium? What is this denser medium? Rarer medium means it is a medium in which the speed of the light ray is more comparatively other medium is known as rarer medium. Understand? So similar way, what is denser medium? Denser medium means it is also a medium in which the speed of the light ray is less, is known as denser medium. Rarer medium means speed of the light ray is more, denser medium means speed of the light ray is less. So this is the way we can differentiate that by using the speed of the light ray, the mediums, denser or rarer. And next here one more physical quantity we have, that is refractive index. Refractive index. Refractive index. What is this refractive index? Refractive index means it is equal to the ratio between speed of the light in medium by speed of the light in vacuum. Speed of the light in vacuum by speed of the light ray in medium is known as refractive index. Sometimes represented with n. N is equal to C by V. Sometimes represented with mu, that is also C by V. Here it is a perfect ratio. When this is a perfect ratio, it not having any units. Understand? It is a perfect ratio. It is not having any units. So similar way, one more physical quantity, one more quantity also there. The quantity is relative refractive index. Relative refractive index. relative refractive index is equal to C by, this is also relative refractive index means it is a comparison between the speed of the light ray with vacuum. Now here it is also comparison between the speed of the light ray between the speed of the light ray, but here between two mediums. The comparison happened, the speed of the light rays within the two mediums is known as relative refractive index, that is V1 by V2. So this is a relative refractive index RRI, relative refractive index. And here even we can write in another way, relative refractive index 1 2 is equal to mu 2 by mu 1, or n12 is equal to n2 by n1. This is also representing the relative refractive index. Here this is representing refractive index of the first medium with respect to second medium. This is also same thing representing that. So this is a relative refractive index and refractive index. Why this refractive index is useful? We can use these refractive indexes to say any medium is rarer or denser. If the refractive index of the medium is more, then we can say the medium is a denser medium. If the refractive index of the medium is less, we can say that less denser, rarer medium. So that is the purpose we are using this refractive index and relative refractive indexes terms. Understand? To say which one is rarer medium, which one is denser medium, we will use this refractive indices. Understand? And next one more concept is there, that is Snell's law. Snell's law. What is this Snell's law? Snell's law is telling that it is also relating the refractive index of the medium, but in terms of the angles. Just now we have seen that we have given a relation between the refractive indices, okay, and speed up. We have given a relation of refractive index by using the speeds. But whereas Snell's law is giving the relation of refractive index by using the angles. What is that angle? So it is telling that the sine function of angle of incident, the ratio between sine function of angle of incidence, angle of refraction is equal to constant. Understand? The ratio of sine function of incident angle and the sine function of refracted angle is equal to constant. But unfortunately, this constant value is equal to refractive index. So I can write sin I by sin r is equal to mu Rn. Okay, sin I by sin r is equal to mu. Even we can write this equation in another way, that is n1 sin I is equal to n2 sin r. Okay, better note down. Excuse me. And next, after this, we have one more terminology. The one more terminology is TIR, total internal reflection. Total internal reflection. Total internal reflection we are doing. So the total internal reflection, TIR shortly, TIR shortly we call it as a TIR. When total internal reflection takes place. See here, any light ray when it is traveling from denser medium to rarer medium, any light ray traveling from denser medium to rarer medium, when it is incident with critical angle, when it is incident with critical angle, what going to be happen? The refracted light ray will grazes the boundary of the two mediums. In this case, refracted angle is 90 degrees. Understand? When any light ray traveling from denser medium to rarer medium, when it is incident with a critical angle, the refracted ray is follows the or grazes the boundary of the two mediums. If you incident more than critical angle, if you incident the light ray with more than critical angle, the refracted ray will not enter into the other medium. Instead of that, it will come to the same medium. Even though we are having two optical mediums, but the light ray will not enter into the other medium because we are incident with more than critical angle. So in this case, the light ray will enter into the same medium. This phenomena is known as total internal reflection. Based on the total internal reflection, nowadays we are having what is the applications of the total internal reflection. What diamond? Okay, diamond also appears very bright because of the total internal reflection. Even though optical fibers also working on based on the total internal reflection, and many applications nowadays we are having based on the total internal reflection. These are the some few main important applications. Okay, so here to execute a total internal reflection, what is the condition must be satisfied? The very first condition is the light ray must travel from denser medium to rarer medium, and it is incident with more than critical angle. So that is the two conditions. If it is satisfied that light ray, so surely it will have the total internal reflection. Even you will get mirages because of the total internal reflection. Where you will observe these mirages? In the deserts you will observe the mirages. Even on the sunny day you will observe the mirages on the our roads, main roads. Okay, this is some important points related to total internal reflection, and this is Snell's law. Okay, and next refraction at what glass surface. Refraction at glass, a thick glass. Let us take a thick glass here. I am taking a thick glass. This is a thick glass. When this is a thick glass, now I am sending a light ray here. This is how the light ray is sending. Now I am sending the light ray. This is how I am sending the light ray. Now this is incident ray. Now the light ray is passing from where to where? The light ray is passing from which medium to which medium? The light ray passing from which medium to which medium? Air medium to glass medium. But here glass medium is more denser than air, so it will bend in which direction? The light ray will bend towards the normal. This light ray will bend towards the normal. This is the way the light ray will bend. Now here also, again across other surface, the light ray is passing from where to where? Across the other surface, the light ray passing from where to where? This medium to this medium, denser medium to rarer medium. In that case, it will bend away. So now look at here, this is the actual path of the light ray, but this is a emergent light ray. Here what happened? The emergent light ray have got shifted because of this glass slab. So the glass slab is utilized for shifting the path one position to other position. So this is what refraction at glass. So how many times the refraction takes place across the glass? Here 2 times. In that, this is called incident light ray, this is called refracted light ray, and this is called emergent light ray. So this is what we have for your refraction chapter. Let's do now some problems related to this concept one by one. I'll share for you the problems. Shall I give problems?
Yes, sir.
No, this is the first problem. This is the first one. See, light travels through diamond with a speed of 12397 km per second. What is the refractive index of the diamond? Tell me the answer. So which formula you supposed to use to find the answer, to find the answer. Yeah, tell me which formula. Yeah, surely we can use the formula, the refractive index. They are asking the refractive index, so we'll use refractive index formula. Refractive index formula is n is equal to c by v. So n is equal to, already they given c value, velocity of light in A already mentioned here, that is 3 into how much? 3 into 10 power 5. 3 into 10 power 5 upon 1.2 1.2 1 2 3 1 2 3 4 5, yeah, 1.2 into 10 power 5. Okay, this is also kilometer per second, upwards of kilometer per second. Now you can cancel these two. So n is equal to 30 by 12. How many times? 3 tens are 3 fours are. 1 by 4 value is 0.25 into 10, which is equal to how much? 2.5. So the refractive index of the diamond is 2.5. Approximately how much is the answer? Approximately you can take option A. Understand? 2.42. Next, the same way, if the refractive index of the glycerin is 1.48, is water is 1.33, print glass is 1.6, and diamond is 2.1, then the speed of the light ray is maximum in. So here, this, the speed of the light ray maximum in which medium? Denser or rarer? Surely it is in rarer medium. Okay, but here for which medium? For the rarer medium, the refractive index value is less. For denser medium, refractive index value is more. For rarer medium, refractive index value is less. For denser, refractive index value is more. So now among all the mediums, which has less refractive index? Surely the water has the less refractive index. So the water surface, the water medium has, in the water medium, the speed of the light ray is more. So the answer is what? Option B. Understand? Next, the velocity of the light in the glass of refractive index is 1.5 into 1.5 is 2 into 10 power 8 meter per second. Its velocity in certain liquid is found to be 2.5 into 10 power 8 meter per second. The refractive index of the liquid with respect to air is, tell me. So here they are asking that the velocity of light in glass medium is glass medium refractive index of the glass medium is 1.5, and the speed of glass in a glass medium is 2 into 10 power 8 meter per second, and its velocity in certain medium is found to be, so same other medium is 2.5 into 10 power 8 meter per second. The refractive index of the liquid with respect to A. So here, for knowing that, so first of all they are asking to find the velocity in the glass refractive index is for velocity of the certain liquid with respect to A. Yeah, easily you can find air medium refractive index you can take by using the Snell's formula, by using the refractive index C by V. C value is 3 into 10 power 8, in another medium is 2.5 into 10 power 8. So cancel this here, 2.8 gets cancelled, 30 by 25, so 5 6 are 5 5s are 6 by 5, which is equal to 2 into 2, that is 1.2. So which one is the 1.2? So here this is a 1.2. Refractive index of that medium is 1.2. So that way we can find the answer. Understand? And next, the refractive index of the water and the diamond are 1.3 and 2.4 respectively. The refractive index of diamond with respect to glass. This is also we can find easily. So I am taking this question answer. Here they are asking that they given diamond and water refractive index, and they are asking to refractive index of the diamond with respect to water. So here, so this is nothing but relative refractive index, that is N2 by N1. Here N2 is a diamond refractive index, that is 2.42. N1 is a water, that is 1.33. So simplify it, you will have the answer. How many times it will go? How many times it is? Tell me how many times? How many times? 2.42 divided by 1.33, that is 1.81. So where is that 1.81? So here approximately you can take 1.82. Next, the diagram shows a ray PQR traveling through a glass slab. Which option is the table give the correct name of for 3 rays? So here this is what kind of a incident light ray? This is a refracted light ray, or is a emergent light ray. So which option is showing the same thing? So the option B is showing the same thing. So answer is 2. Understand? Next. Next, see that 61. The refractive index is 1.5 and of water is 4 by 3. If the velocity of the light in air is 2.25 into 10 power 8, then the velocity of the light in the glass is velocity of the light in the glass. Here they given glass medium refractive index and water medium refractive index. In the water they given refractive index of the glass 1.5 and that water is 4 by 3. Velocity of the light in water is 2.5, then velocity of the glass is. So this also we can find by using the relative relation is n is equal to c by v. So from here v is equal to c by n. V is equal to c value 3 into 10 power 8. N value already mentioned for glass, that is 1.5. So V is equal to 1.5 1 za 1.5 2 za 2 into 10 power 8 meter per second. In the glass medium its velocity is 2 into 10 power 8 meter per second. That is the first option. And next, the refractive index of the dense flint glass is 1.65 and for alcohol is 1.36 with respect to air. What is the refractive index of the dense flint with respect to alcohol? So this is the asking relative refractive index. You can find relative refractive index by using the formula N12 is equal to N2 by N1. N2 is denser value, that is 1.65. N1 is alcohol, that is 1.36. So take the ratio, you will have the answer. Tell the answer. 1.65 by 1.36. divided by 1.36, that is 1.21. So first option. So what is the answer? 1.21. So the option 1 is the correct one. So this is the answers. Next I will go for the next slide. The water level in a bucket is 40 centimeter. Actual depth of the water, if the refractive index is 1.3. So here, actual depth of the water is they are asking. Here, this is a concept of real depth and apparent depth. Okay. So here, apparent depth is equal to mu times of real depth. Apparent depth is equal to mu times of real depth. No. 1 by mu times of real depth. Apparent depth is equal to 1 by mu times of real depth. So use this formula, you can find out. So apparent depth, they are asking that real depth. So now they are asking that real depth. Real depth is equal to mu times of apparent depth. Mu times of apparent depth. Mu value is 1.33. Apparent depth is 40. So totally how much? 13.3 into 4. 13.3 into 4. What is the 13.3 into 4? 13.3 into 4. 13.3 into 4. 13.3 into 4, that is 53. So option 3 is the correct answer. So here 53.2 centimeter is the answer. And next, the apparent depth of the oil in a vessel is 16 centimeter. If the real depth is 24 centimeter, find the refractive index of the medium. So same formula, this formula we are supposed to use. So use this formula. They are asking to find mu is equal to real depth by apparent depth. Real depth is apparent depth is 16, real depth is 24. 24 by 16. 24 by 16, how many times? 24 divided by 16, that is 1.5. So mu value is how much? 1.5. That is a first option. Next, same way, a small object is immersed in a liquid of refractive index is 1.5. If the real depth of the object is 18, calculate the apparent depth. Same formula again. Apparent depth. They are asking that apparent depth is equal to real depth by refractive index. Real depth they given 18 centimeter, apparent depth given 15. So 180 by 15. So how much is the 180 by 15? What is the value of 180 by 16? 180 by 15, that is 1.2. So 12. So that is how much apparent depth is 12 centimeter. So option A is the correct answer. And so this way, look at the 70th question. Diamond shines because of what? So what kind of answer it is? Last question. Total internal reflection is the correct answer. Even in the diagram, the coin just out of sight, if the poured into water metal, the coin will become visible, appear smaller, remains float at the surface. Which one is the answer? Initially it is out of sight, but if pour the water, we can see and become visible. That is the first option. Okay. Next, if atmospheric refraction did not occur, how would the apparent time sunrise and sunset be changed? Both would be later, both would be earlier. Sunrise would be later, sunset would be earlier. So tell me. Actually, sunrise would be because of the atmospheric refraction. Sunrise happened earlier, sunset happened later. So what going to be happen, this could be reverse. So what is the reverse case? Sunrise would be later, sunset would be earlier. So this is the this is the answers. And next, so I will stop the session for today. So this is the questions related to the light chapter, refraction, only refraction you have. Remaining questions you can do, and you have exam on 5th March 5th, that is the final exam. You will get questions from all the topics. Understand? So be careful, revise properly. So I will stop the session for today. Understand? Bye.